4.4, the fundamental theorem of calculus. The fundamental theorem of calculus is pretty straightforward. It's actually very fundamental and important. If f is continuous, if a function is continuous on the closed interval, and capital F, meaning the integral, is an antiderivative on the interval, closed interval, then here's how you find the definite integral. A definite integral means you have a number from one point to another. This is called a definite integral. You're going from something to something, A to B, from A to B. So the area under the curve, basically, capital F means antiderivative or integral of f. So all we basically do is take the integral of f of x, plug in the b, plug in the a, and subtract the 2. To find the area under the curve on an interval of a function, you integrate, plug in b, plug in a, subtract. It's actually very simple. All right, but it has to be continuous, and it has to have an integral. Integrable is a weird word. Mean value and average value, basically the same thing. Mean value is your average. Here's the area under the curve. If I have a graph, say like this, I could find the area under that curve. All right? But there is an area underneath that curve of a rectangle that matches that. Meaning, I can make a rectangle from here to here. The area under the blue line would probably be very similar to the area under the orange line. It's not perfect, I just sketched it. But the area under the orange line is the average, is the mean value of the area under the blue line. Now, this is A, this is B. This length of a rectangle is B minus A, right? Isn't that simply B minus A? B minus A? This height is f of c. Isn't the area B minus A times f of c? There is some rectangle, you can make some rectangle that has that same width, B minus A, but has a height f of c. That would equal the area of the blue shape. So there's some rectangle that matches the area of the blue shape. That f of c is important. Now this is called the mean value theorem. It's basically saying there is some rectangle equal to that. This is basically worthless in my mind. What we want from it is the average value usually. It's not worthless, but it's less important than this formula. Now all they did is took this formula and changed it to get this formula. All they did is simply, to get from this to this, they simply divided both sides by B minus A. You see, if you divide both sides by B minus A, you get this formula? This is the more important one, meaning the average height of the graph is equal to the area under the curve divided by B minus A. Because when you multiply by the reciprocal, it's divide. So the average height is equal to the area divided by the width. That's the important one. Average value on the interval. Meaning, look right here back at this graph. Those 2 points are the average height of the graph. For this blue graph, at this point and this point, you have your average height of the whole graph. It's kind of really important. The last thing is the second fundamental theorem of calculus, and it's actually kind of easily done. If you take the integral of f of t dt on the integral a to x, and then you derive it, your answer is f of x. Here's why. If you integrate this, do you understand? You first get f of t, and you go from x to a. Whenever you integrate, you put a capital F. Anyways, to do this, you now have f of x minus f of a. Okay, that equals the inside. Now when you derive this, What happens when you derive this? Well, you derive this, okay. You're going to ddx this. What's the derivative of this? If you take capital F and you derive that, doesn't that take you back to lowercase f? If you take an integral and you derive it, it takes you back to your original. When you derive f of a, well, f of a is a number. If you derive, say, 4, what do you get? Sorry, let me start over. This is the integral. Yeah. And you plug in a. When you plug in a, you get a number. Again, what is the derivative of a number? 0. So aren't we adding nothing to it? The derivative of a number is 0. So basically, this ends up becoming f of x plus 0, which is this. You don't want to do all this mess I just showed. It's easier just to think, okay, if there's f of t here, I go from some number to an x, and then I derive it, it's simply f of x. This takes some time to practice. I'll have to do this more with you. It's kind of weird.